Okay. First of all, I got to explain what is a radian. All right. And I was thinking about, where's my string? There it is. Thinking about giving you guys string and doing this on your own. But I was like, you know what? You're seniors and you just want to get right to it. So here's a radian measure. Here's what a radian is. Everyone see this little line I drew in on your packet? What's that called? From your geometry days. What is that? The radius. Yep. So if I took a piece of string right now, measured the length of the radius with string here, so right about here, and then I measured an arc that's got the same length as the radius. Okay, so again, I measured the radius, and now I want to find a portion of the arc that's got the same length, so I'll say it's from here to here. Okay, so if this is my radius, this is also the radius length right here on the arc. So both of them measure the same length. When the radius and the arc length are the same, that angle that's formed, see the angle we formed right there? That is 1 radian. All right, that is how a radian is formed. 1 radian occurs when the radius measure matches the arc length. Both of them have the same length. Now, if I kept that same piece of string and kept going around the circle, let me tell you how many of these I'd be able to form. And I'm just going to eyeball this in here. So I find another radian right there. There'd be another radian right there. Another radian right there. Another radian. What do I have? 1, 2, 3, 4, 5, 6. A little more. Okay, this is what would end up happening. I would be able to form 6 radians and a little more. If I went all the way around with my piece of string, I'd be able to fit it on this circle 6 times and just not get a full 7th one, just get a little piece after 6. Megan, question for you. How many degrees are in a circle? Darn right there is. 360 degrees in every circle. We all definitely agree on that fact. So now what I just showed you is 360 degrees is the same as 6 and a little more radians. But hey, Patrick, you tell me, is this really mathematical for me to do this as a teacher? 360 degrees equals 6 and a little more radians. You would never accept that. That's ridiculous. That's embarrassing for me to write that. That 360 degrees equals 6 and a little more radians. So we need something more precise. Go to your calculator right now for me. Type in 2 pi and let me know what the decimal answer is. What are you guys finding when you type in 2 pi? What's the decimal equivalent? 6 and a little more. Okay, so we're not going to say 360 degrees equals 6 and a little more radians. We're going to say 360 equals 2 pi radians. Okay, 2 pi. That's much more exact than us saying 6 and a little more. So you guys now, because I know a lot of you are very clever here, what would 180 degrees be equal to then? 360 was 2 pi. What about 180? What do we think for 180 if I'm just cutting it in half? Lucas, what do you think? 1 pi radian. Yep, pi, or 3.14 radians, right? It's equal to pi radians. So here's the question of the day then. If I have 1 radian, right here, 1 radian, how many degrees does that turn out to be? That's what I want to know. That's the big question of the day. 1 radian, how many degrees is it going to be? So basically, how many degrees here? How many degrees in that angle? How many degrees in that angle? Okay, well, how can we figure out? Well, what I want to do with you right now is set up a proportion. Okay, you already know here. Here we go. Ethan, how many? 360 degrees is the same as what radians? 2 pi. And Isabella, I'm trying to find out How many radians now? 1 radian. So where should that go? Across from the 2 pi radians or across from the 360 degrees? And I'm trying to figure out how many degrees that's going to be. How do you guys solve proportions? Cross multiply. All right, let's do it. Let's cross multiply. 2 pi times x equals 360. What are you guys going to divide both sides by? Just 2? Or can I get it all done at once? 2 pi, yep. I would highly recommend a fraction template if you have it. If not, please make sure the 2 pi is in parentheses. Please make sure the 2 pi is in parentheses. So what's 1 radian turn out to be? Round to the nearest tenth for me. Let's make it easy. Round to the nearest tenth. 57.3 degrees. Okay, so 1 radian is going to be 1 radian only, 57.3 degrees. So all these angles I made here, 57.3 degrees. Okay? Knowing that knowledge right now, can I see you answer questions 1 and 2? Now that you know 1 radian is 57.3 degrees, go ahead and answers 1 and 2 for which quadrant will it be in. Okay, so I have 2 radians now. Which quadrant am I in? 7 radians. Which quadrant am I in? I just shown you guys, hey, 1 radian, 57.3 degrees. Okay, let's go. Here we go. Number 12. Who's got 12? 12? Emma, what quadrant did you find 2 radians to be? Quadrant 2. Here's how Emma got it. She knew 57.3 radians in 1, or degrees in 1 radian, but she's got 2 of them. So multiply that by 2. We're at 114.6 degrees. And she used her knowledge from yesterday to know what quadrant that was in. All good. Okay, how about an angle of 7 radians then? Where do I end up now? How about 3? Who's got 3? First quadrant. Again, how did we do it, Isabella? We took 7 and you multiplied it by your 57.3. And what'd you end up with that? 400 something? $401.9 degrees. And then from her knowledge from yesterday, that's got to be in quadrant 1. Anything on those right now before we get on to the next part? Going? Okay. Whoa. We run into a problem, though. Remember at the beginning when I said 6 and a little more? And Patrick laughed at me like, that's ridiculous. I'm going to laugh at you now. We need something more precise than 57.3 to multiply by. Okay, because we could be off by a couple of degrees here or there now. We need something more precise. And that more precise is on your reference sheet right now. Everybody, please take a look at your reference sheet. Thank you. And does everyone see where it says radians? Everyone see on the reference sheet where it says radians? All right, we're not going to multiply by 57.3 anymore. We're going to multiply by 180 over pi. In your calculator right now, just so you guys are comfortable with me doing this, do 180 divided by pi and tell me what you're really multiplying by, basically. What's 180 divided by pi? 180 divided by pi? Are we all getting different answers? Or what's it about? 57.3. It's a little bit more exact, though, all right, than cutting it off at the 3. All right, so that is what we're going to multiply from now on if I need to go from radians to degrees. It's 180 over pi. We all ready to do that? We all ready to do that? There we go. Okay, here we go. This is what's on your reference sheet already. Convert 7 pi over 6. Ready? Before we do anything, Everyone see the pi there? That tells me radians, radians, radians. If I see a pi in the measure, that's telling me you're in radians right now. You are in radians. And I want to go to degrees. Okay, so that we just determined 57.3, not exact enough. So I go radians to degrees on the formula sheet. Do you see why I'm picking this one instead of the other one? I'm going from radians to degrees. So we're going to multiply it by, not 57.3, but what now? What are we going to multiply it by now? 12? What's my, not 57.3, instead we're going to multiply it by what? 180, not just 180 though. Over, what's there? What's on your reference sheet? Pi. Does everyone see that? Now we're multiplied by 180 over pi. Annika, we good? Beautiful, because what cancels out now? Pi's are gone. One's in the numerator, one's in the denominator. Those are gone. And now I'm just doing 7 over 6 times 180. Or 7 times 180 over 6. And we're going to find out 7 pi over 6 radians is the same as how many degrees? Who's got 8? $210 degrees. Do we see that going? Okay, well, I'm going to jump around here in the notes. Okay, I'm not going to go to number 4 right now. Are we, stop everybody right now? Are we okay here? No more multiplying by 57.3. I want you to multiply by 180 over pi if you're trying to go back into degrees. We all good? Good? I didn't think you were going to, somebody told me you were going to be here today, Emily. Is your sister on a field trip?
Yeah, I think so.
Well, somebody in third period said that you were on it as well. No? Okay. Where are they going?
I think courthouse. I don't know.
Oh, this is the law class? Okay, gotcha. All right. They'll be on 8,000 field trips by the end of the semester. This guy's got the life. Okay. Remember I told you at the beginning, pi signifies radians? Sometimes pi won't be there, though. Go down to number 5 for me, please. Go down to number 5. Remember I told you yesterday we'd be seeing this bad boy, theta? Just means angle, right? Just means angle. Okay. Convert each of the following radian angles. So, hey, this is 5.8 radians. Does it have a pi with it? No, don't put one then. It's telling you it's radians. All right, don't put a pi with it because you think every radian has to have a pi. No, I'm showing you right now. This is 5.8 radians. Look at the conversion. What should I multiply it by to get to degrees still? Not 57.3. What's our new conversion now? 180 over pi. All right, there you go. So take 5.8, multiply it by 180 over pi. There's no pi's to cross out, so put it into your calculator and round your answer to the nearest degree. Nearest degree, what do we end up getting? What do we have here? Who's got 9? 9? Reagan, hello. 332. I'm doing well. Thanks for asking. 332. Good job. Lucas, we good here? What about the rest of your group over there? What about your boy in the back? Okay. That's all I needed. Looks pretty good. Negative 2.5. I don't care that it doesn't have a pi with it. I don't care that it's negative. Here we go. Negative 2.5. Still multiplying it by not 57.3, 180 over pi. Still rounding to the nearest degree. And you ended up with what here? 2. What do we end up with? negative 143 degrees. Solid job, everybody. Solid job. Anybody? Questions? Right? Hey, radians to degrees. Anything? Radians to degrees. You ready to go backwards now? We ready to go backwards? Now go back to 4 degrees to radians. Degrees to radians. So you have 120 degrees. How many radians is that? Well, what's the conversion now? Not 180 over pi, but if I'm going from degrees to radians, what's the conversion now? Multiply by pi over 180. Don't try to get ahead of me. Don't try to get ahead of me. 120 times pi over 180. But, oh, whoa, easy with the calcs, kids. Easy. Remember what we said with radians. Most likely they're going to have a pi in it, right? So your answer here is going to have a pi in it. Don't put it in your calculator. All I need you to do is, what's 120 over 180 simplified? That's what you need to do when you convert it into radians. Keep the pi in the answer, so don't put it in your calculator. 120 over 180, reduce it for me in your calculator. Is it 2/3? Is that what it is? So 2 pi over 3. Leave the pi in there. Don't put it in your calculator. Because that's how I'm going to know you put it in radians, with the pi there. Okay? Don't put it in there. I don't want any fancy decimal. Leave it there. Oh, Matt needed... Oh, sorry. Go ahead. I was going to throw you under the bus. But go ahead, Megan. Where would you like it? Oh, if you want to. Sorry, my way's not good enough. 2/3 pi. Don't put it in the denominator, though, because it's clearly not in the denominator. Okay, sorry. My bad. My bad, Megan. Sorry, never happened again. Matt wanted an extra one here. You got it, Matt. Question 4.5. Give me an angle, Matt. 200? All right. Let's convert 200 degrees now to radian measure. 200 degrees to radian measure. So look, degrees to radians. Look on your formula sheet. Degrees to radians. Multiply by pi over 180. Again, keep the pi in your answer. Reduce 200 over 180, though, for me. $200 over 180. And that reduces down to what? 14? 200 over 180? You gave her a number and she's not even here. That was the point of doing this. 3. 10 ninths. Pi. There it is. Is that good, Megan? Far enough away from the fraction line for you? Okay. Questions? All good? And I didn't think I'd be standing here a week later saying that your video might be the best out of all those I've seen so far, which is the dehydration one today. I didn't even know what was going on. It's like I was at a rave or something with everybody dancing around and the lights and everything. I was like, all right, enough's enough. Yeah, they're pretty good. Yep. Questions right now going back and forth. Do you feel comfortable going back and forth? Because here's the next part of this. Everything you did yesterday, remember, Matt, you gave me the 220, right? But now I'm going to start off in radians now and ask you to do the same exact things. But I'm going to start off in radians. Okay? You feel comfortable there, Isabella? We'll find out. Here we go, kids. All right, let's do this. Find a positive and a negative angle. I did that with you today with degrees. But now what did I start you out with? How do I know this is radians, by the way? Got the pi there. So I want a negative and a positive angle that share the same terminal side with 5 pi over 2. Now, as people are getting, oh my, what am I going to do now? I got radians. I don't know how to deal with it. You knew how to deal with it yesterday when it was in what measure? Oh, you knew how to deal with it in degrees. So why don't we take 5 pi over 2 and do what? Put it in degrees. And then you guys can handle it. So go ahead. Take 5 pi over 2. Let's convert it to degrees before we do anything. What conversion are you guys multiplying it by? Just to make sure we're all on the same page. Who's got 13? Okay, ready? And people get confused on day one. Where do I look on the formula sheet? You're going radians to degrees. So that's what you want to look at on the formula sheet. Radians to degrees. What do I multiply it by, Vinny? Yep. And here's always a hint. You want to get that pi out of there, right? So make sure it's on the bottom. That helps you out. Make sure it's on the bottom. So this is the same thing as what in degrees? What is that in degrees then? Who's got 17? 450? Can I get a confirmation from everybody? 450? Okay. You guys know what, I know, what did we do? What did we do yesterday if I gave you 450 and I wanted another positive angle and a negative angle? So let's start with the positive angle. How can you find me another positive angle with the same side? Who's got 5? 5? Hi, Annika. How are you? Unbelievable. What can I do with the 450 to find another positive angle? Sure. So 450 plus 360. What's another positive angle there, Annika? 810. Thank you. I like it. All right. Who's going to find me the negative angle then? That's got the same terminal side. The negative angle. Who's got 12?
Subtract 360.
Okay, you got it. You got it, Emma. 450 minus 360. That's going to give me what? 190? Okay, what's the problem though? Still positive, so what do you want to keep doing? You got it. Subtract another 360. And that'll be negative. Okay. Patrick, ready for the bad news? We are correct. You guys did find me a negative and a positive angle. You are correct. What did I start out in though? So you have to end that way. Okay? We started out in radians, so you need to end that way. So what am I going to have to do right now to 810 and negative 270? Go back into radians. Nice job. Good talk, everybody. So yes, take 810, convert it back into radians. Simplify. Take negative 270, convert it back into... When I say convert it back into radians, I'm asking you guys to multiply each of them by what? Pi over 180. Perfect. Again, keep the pi in your answer. Don't put it in your calculator. Reduce 810 over 180. Who's got 7? 7? Okay, here we go. What did 810 over 180 reduce down to? 9 over 2. 9 pi over 2. Sorry, Megan, deal with it. I'm running out of room. All right, 9 pi over 2. And what did negative 270 over 180 reduce down to? 17? Yep. All right. Everyone okay? If you start out in radians, yes, you do have to end in there. Now, a lot of you are, that is so much work, going from this radian and going back to degrees and going back here and back there. I get you. You're correct. Is there a different way I could have done this problem? The answer is yes, and I'm going to do it the different way for part B. What did you guys keep adding and subtracting here? You keep adding and subtracting 360, which is what in radians? 2 pi, isn't it? So if you don't want to convert it to degrees, you can just take your angle. Here you go. Let's do it with 4 pi because it's very easy. You can take 4 pi and add what? Instead of 360, add 2 pi. And you're going to end up with 6 pi, already in radians. Don't need to convert a darn thing. You like that, Ethan? You're darn right, because you're doing the next one. Ready? 4 pi minus 2 pi gives me, but what's my issue? It needs to be negative, so keep doing what? Subtracting 2 pi. Ooh, I get a 0 there. That's not positive or negative, so keep subtracting 2 pi. And Ethan, it ends up, the negative angle ends up being negative 2 pi. So if you don't want to convert, you can add 2 pi and subtract 2 pi. All right? Questions? See that, Matt? Now, Matt's asking himself, well, why didn't you show us that trick on the last problem in part A, right? Well, here's why I didn't show it to you. 5 pi over 2, and you're saying add 2 pi? They have different what? If you can handle that, go ahead with different denominators. That's fine. That's something we did in the unit 1. All right? If you want to add those up with different denominators, that's fine. Okay? But yes, you can still add and subtract 2 pi. Questions? Okay, I don't know if this is a good idea or not, but I need you guys to feel a struggle a little bit. Sketch the angle, find the reference angle. Well, we did this yesterday, correct? But your angles were all in what measure yesterday? Degrees. Is there anything stopping you from putting it in degrees first and doing it? Nope. Just make sure, hey, please make sure your final reference angle is in radians. Okay, I will be going around to each group right now helping you out. All right, so negative 5 pi over 6, sketch it. Find the reference angle, but make sure the reference angle is in radians at the end. So again, convert it to degrees before you start. Make your life easy, convert it to degrees. I'll come around and help you out.